All right. So this is basically the slides for Chapter 4. Make sure we go over everything covered so it's clear. And then we'll jump over to IntelliJ, or while I'm doing this, I'll jump over to IntelliJ and show you more about class design and how you actually integrate classes, or class uses another class or has a class. So name of a class, the name of a class is important for several reasons. Obviously you need to identify it. It must be descriptive, and it's important because it provides what the class does and interacts with larger systems. Basically, before you just pick a class name, think about it. What do you want the class to be called? What do you think? How do you think it's going to be used? What should it represent? Take the time to name your classes carefully. This is more important than with variables, because if you mess up the class name, it can be a pretty big refactor to go back and change the class name in all your code. So think about the class name before you actually write it. All right, comments. They're vital. I think Dr. Hayes did a pretty good job here. Comments in Java are just like in C++. He's a better commenter than I am, so you can stick with commenting your code.
If you know what it does, that's all that matters.
What was it? If it was hard to write, it should be hard to read.
Yeah, that's right.
No. Guys, if the code's hard to understand, make a comment just to explain it real quick. I'm on that side of the fence. Comments are important, but you don't need to go crazy. Attributes. What's an attribute?
A characteristic.
A characteristic. Okay. What type of characteristic?
I know my synonyms.
What are the attributes in student?
Name.
Name and... All right, so they're the member variables. Name and ID. In menu design, all attributes are private. In general, that's the way you want to do it, unless you have a specific reason to make something public, which usually is not what you want.
So if it's private, can you still scan in something? Have an input?
Yes, you could always have setters and getters. Methods. What's the method if that was the attribute? Yeah, the functions.
What it does.
What it does. There you go. All right. Invoke certain behaviors. One of the uses is accessor methods. Accessor methods means you're accessing something. So, for example, get name, you're getting the name, you're accessing the name. That just returns the name. Yeah, so you're a get name. Sometimes they're referred to as getters and setters. I call them getters and setters. If you were learning C#, it's explicitly get and set. But here, this is how we set up getters and setters in Java. This is the convention.
All right, so I know I probably should know this already, but
I agree.
when you're using getters and setters, you use those in your function, and then in the main, have the getter.
The getter will get it. The set actually sets the value. So you want to set the value and then get it later.
Okay.
Okay? All right.
So maybe you set the value in the main, or
When you need to. It depends.
do you have a user input?
Right, so then you'd call .set right after the user input. Public methods. What do the public methods describe?
It's a method available to all your functions.
All right, and what's the word I'm looking for? It is the of the class. Interface, there we go. Got to keep that in mind. It's the interface. It's how you agree other classes to communicate with your class, or other objects to communicate with your object. Notice we have got some constructors, but we also have get name and get ID as well that are part of the interface. Private methods. So you can't have private methods, and that's something to be hidden from other classes. These are usually something to help do something internally. Hopefully I'll get you a good example of this later, but there might be methods that just help clean up your code so it's easier to understand what's going on, but you don't want other people calling them, so you make it private. Great, that was nice and short. Okay, so let's go ahead and jump over to an example. Is that too hard to see from back there, or you got it? Or you want me to turn off the light? Things can get really dark.
Yeah, I like it.
You like it? All right. Back to our natural environment. Okay. So beforehand, I talked about a student object, and we stated, hey, look, the student object is going to have an ID and a name. We decided that you can't have an empty constructor. You have to construct a student with at least a name, preferably an ID. But if you only have the name, we'll just set the ID to 0. And maybe we'll have a string with to get the name, or a function to get the name and get the ID, and another function to figure out what the current student count is. All right, and I was trying to start showing you about how you can compose essentially classes inside of classes, or an object can contain other objects. This is very useful and will be very necessary for your next lab. But so here we have our student, and I was saying maybe we'll have a classroom object that will model a classroom. And I said that first off, your classroom will have a name, and it'll have maybe an array of all the seats that are in the name, or in the classroom. We talked about arrays, or y'all talked about arrays in C++. They're going to behave a little similar right here, and I've actually done a little. But when you construct your classroom, ooh, that was interesting. You have your name, number of seats, and then you construct basically your seats will just be an array of students. Since it's an array of objects, they're initially null, which means that if you try and get something at a certain position, it may return null. But I did have a way to set which seat's in there. All right, if I jump back into main, let's see, do I have a classroom main or just a student main? All right, we'll do a classroom main. New Java class. Classroom main. We'll add it here. Public static void main string args. Okay, so here I can make a class room. We'll call it AH208 equals new classroom. And what are we going to add to it? So it's name, AH208. And how many seats are in this room? Ooh, does anyone know?
I'm not good at counting.
The sign of a true computer scientist. I believe there's 24 in here. Okay, so I have 24. If I were to immediately afterwards go system.printout.println ah28.get seat at position 0, what do you think this will print out? What is it going to print out?
Go back to the classroom.
Sure. Jump back to the classroom code.
You said get seat, right?
Yes.
So there's nothing of that.
Yeah, so then what's going to be returned?
No.
Null. There you go. There we go. Null. All right. So obviously nothing's there. So we go ah208.setSeat, position 0, new student. Who should we put there? Who's in 0? Good old Tyler. Actually, which position are you in, Tyler? You don't know?
How do you, like, how are we,
I'm
going to say 3.
You're on 3? All right, we'll give you number 3. But wouldn't that actually be 2? 0, 1, 2?
There's still a seat there. Just nobody's in it.
Oh, I see. So we're going to say 2. And then we'll say in 0, we have Stephen there. Whoops, I'm used to VI. All right, so now if we print out .0 and .get name, and then we'll also do it on 2, what should be printed out?
Stephen and Tyler.
Stephen and Tyler. There we go.
Wait.
I switched the order just to make sure you were paying attention. Okay. Okay. Let's add a couple more. What else do we have? This is where I get to relearn everyone's name because I forgot them all. Tyler. The guy next to Tyler. What's your name?
Matt.
Matt? Oh, thank you, Matt. What's your last name, Matt?
Webby.
Wimby. Oh, okay, Wimby. Wimby with a B, right?
Webby.
Thank
P.
you.
With a
Yes.
P.
With the P?
Yeah.
Oh, okay. And the leak is over here. What's your name, sorry? Bronny. Thank you. Oh, wait, say it again? Bronny, okay.
Ronnie.
Ronnie. Thank you, Ronnie. Could not just escape my mind at the last moment. Sorry.
Ben.
Ben? Thank you, Ben. And hold on, I might know this one. Philip?
Yeah.
Oh.
About PJ.
PJ. Okay. That was close. Almost had it. PJ. So if I go down here, let's put 4. What should that print out? Yep. All right, great. It's also kind of cool. So I can do student.out.println. Ooh, let's see who remembers this. Student.get number of students count. Ooh.
6, right?
6. Yep. All right. So you see how what I did was the classroom has students in it. You see how that relationship? It's a very common, important relationship in OOP. All right. Let's do another level. Classrooms are part of buildings. So let's go ahead and make a quick building object. A building class. So a building has classrooms. What other attribute does it have?
Offices.
Offices. Okay, it might have an office. Doors.
Stairs.
Stairs. Okay, hang on a second. So we got doors, stairs. I like this.
Rooms.
Rooms.
Windows. Oh, I guess you could say the office is a room.
The office is a room, yeah. So, but we have just classroom right now because I'm trying to keep it simple. So would the doors, stairs, and windows be part of the building or part of the classroom?
Classroom.
The windows and the doors would be part of the classroom.
Building.
Yeah, the building.
Yeah.
Well, it's part of the building, but should it be part of the classroom or part of the building?
The building. Each classroom.
Because
has
the
a-
building, the thing to keep in mind, this is why this is important to think about, is we are going to have classroom, just have classrooms.
We don't have stairs in the classroom.
No stairs.
Right, so, all right, so the stair would probably not be part of the classroom. But should the door and windows be part of the classroom?
Yes.
Yeah. Do you see how I push it down there to maybe simplify a couple things? So we'll go over to the classroom and we'll have, I'm just going to try and make this simple, int number of doors, and what was the other? Num stairs.
Windows.
Thank you. Windows. All right. We'll just leave that there for now. So yeah, we don't need to think about the doors and windows here, just maybe the stairs, classrooms. You said office, offices. Okay. Anything else? Floors? Floors? Stores? Oh, the floors or the stories? Ooh, okay.
I guess that would be for the building
Ooh.
because of how many floors.
Oh.
But
Hmm.
do you really need that if you have because you're not worried about how many floors. The
I mean, yeah, the question is, do we need to add a floor object, or should we just have the classroom list what floor it's on?
that classroom is
Okay.
less work.
All right. Maybe it's floor. All right. So that can be at the classroom level. Student classroom building.
Oh yeah, classroom has the desks. So
Yeah, the classroom would have desks if we wanted to. So we wouldn't have to make that part of the building. Okay, let's go back to building. So we got stairs, classroom, offices, probably the roof. I'm just throwing that in there. All right, what else? The building, it needs a name, guys. So let's go ahead and give the building a name.
can we name it something really crazy?
Sure.
Let's call it yes.
Paul of the West.
Paul of the West, the Paul of the West building. All right. Well, we need to give a constructor. We'll go ahead and disable the default constructor here by making it private, and then we'll go ahead and make a public building. Needs to have a name, and then maybe num classrooms. All right. So then we could have. Whoa, I didn't want me to put an M in front of that. There we go. So M name would equal name, and then we'll have M classrooms equals new. Was it classroom sub num classrooms? Okay. Did I misspell it? Oh, this one needs a capital R. All right. We'll go ahead and do a quick getter and setter on those. So public set classroom into position, and you pass it the classroom. So then you just have M classroom sub position equals classroom. That probably needs to be a void. So I did the setter. Let's see if we can do the getter. What should the getter be? Public. What is the getter going to return? What's the getter returning? So the function is get classroom. So it's getting the classroom. If it's getting a classroom,
So we're going to get the type. So we're going to get it's going to return classroom.
there we go. What needs to be passed to it? Ooh, good question. What should be passed to it?
Yeah, probably position and
Okay, so we can have position. What's another way we could try and get the classroom?
The students in the classroom.
Okay, we could try and search by, yeah, so we could do student. I like that one. That's cool. I'm going to have it return null at first. Anyone else? Anything else? So the student in the classroom. Figure out where they are at this point. Oh yeah, I like that.
what about name?
Ah, name. That was a good one. Yep. I think those are the three. Now, before we continue, of these, Which are the important ones? Which do you think are actually useful? I would actually argue one is not needed.
Probably name's not needed, right?
You probably want to get it by name.
Position.
But position, is position really needed?
No.
Why, do we care about the position? No.
Not this point.
Are you saying name of the classroom, right?
Yeah, name of class. Oh, thank you. Let me make that variable name a lot better. Classroom name. Yeah, so we don't need that other one. I don't think it makes too much. It's needed. All right, let's go ahead and make a quick building main, just so we can start playing with some stuff. I'm going to add that in there. Let's go and do public static void main string args. Boom. All right. I already started one classroom with classroom main. And where did that guy go? So let's at least just go over here. I'm going to copy this code over to building main. I'm going to create a private function, private classroom create AH208. Return AH208. So basically here, creates a AH208 with 24 seats, sets some students in it, and then returns AH208. That way inside of here I can just do building. What building do we want to do?
All the West.
Paul of the West. All right. Equals new building. We'll say it's the name is good old Paul of the West. Oh no, let's do it all lowercase. Keep it like this. I like it. And how many classrooms can it have?
6.
6. All right. I'll do Paul of the West dot set classroom. We'll make 0, and we'll call create AH208. Oh. So we do need to create the building main. I'll just call it VM equals new building main. I take that back. This should be static, private static. Because we want to be able to create AH208, and it's kind of superfluous if we have a building main object or not. So in your main class, everything probably should be static, if that makes sense. So Paul West set classroom 0 to AH208. We should probably create another classroom, and we'll do it similarly. Oh wait, any questions on what I did right here? Ooh. No? Yes.
So when you called set classroom,
Mhm.
you passed it, that's
Zero.
the position that it's going to create it at,
0.
and create AH208. What is the parameter type there?
The parameter type there is what's returned by the create AH208 function, which is a classroom. See where my cursor is? So that function returns a classroom. Notice in here I create a classroom. I set some students. I return AH208. So then it's going to push it back into 0, or position 0 there.
So I guess kind of what I'm asking is set classroom, what do you have to pass that?
So how do we define set classroom in the building?
Okay.
Is we defined it as set classroom. You pass it a position, and then the classroom.
Okay.
By the way, I'm glad you asked that question. Is this function correct?
Sure hope so. I'm not the one that wrote this.
I'm not. I've never promised the code I've written is perfect.
True. That's true.
And in fact, a lot of times I'm going to intentionally not write it perfectly. Here's one of the cases. What's wrong with this function?
You've got.
Is it supposed to be a void
Oh, you
function?
get 2 getters. That sounds like
Well, if it wasn't void, what would it be? Okay. what could I pass to this function to make the program stop executing?
0.
No, zeros.
Well, in classroom, if you pass a 0, but no.
It would just set that to null. So I think that's actually okay. And by I think, I mean I know. But here you go. paulofthewest.set classroom. We'll pass 0, null. Go ahead and run that. Oops, that was the wrong one. One moment. Run building not main. All right, it was fine. No problems.
So it's probably, so you only got 6 rooms in your building, right? So if you set something out of that 0 to 5.
Ah, yeah. What if I put -1 right there? Is that legal to pass?
Oh, yeah.
It is in position. I just need an integer. And if I run it now, what happens? Exception, out of bounds. Ah. So, other programmers and your professor for this class will pass you evil inputs to your functions. So you need to check for them and handle them appropriately. So if position is less than 0 or position is greater than or equal to, what do we have? classrooms dot length, or I should say, if it's greater than, let's keep it this way. I like it this way. It makes it clearer. So if the position is less than 0 or is greater than or equal to length, what am I saying there?
It's out of bounds.
If it's out of bounds, post is out of bounds, what do we want to do?
Return null.
Return. Just return. Get out. So now if we pass -1, it just ignores it. All right. Make sure with your functions you think about inputs that are valid to the function heading. Namely, you jump over here, you can pass -1 or something above the length. That's valid to pass here, but semantically make no sense, and take care of them accordingly. Okay. So we have AH208. Let's create another classroom. So public static classroom. Create. What other classroom do we want to create?
Let's do AH207.
AH207. All right. So classroom AH207. Make sure I spelled classroom correctly. Equals new classroom AH207. And I think there's 15 seats in there. And I'll have it at the end return this AH207 object we've created. All right. AH207.set seat 0 new student. Who should we have? Bob. Oh, Bob, my favorite.
Oh, good old Bobby.
Good old Bob. Bobby drop tables. All right, 5. Who's going to be in 5?
Billy Bob.
Billy?
Billy Bob.
Billy Bob.
Oh, his twin brother.
His twin brother.
Their parents were just really lazy.
All right, we'll have Spider-Man. Wow, we're going to...
Hey, man.
What is happening over
This is a
there?
good class. I might not be.
Yeah, Batman in there too, maybe?
Sure.
Put me on the roster.
Anyone else?
Walter in there.
Walter?
Walter White.
Yeah,
Walter White.
it's a good class. It's chemistry class.
Chemistry class? Ronnie, what'd you say?
Jeff.
Jeff?
Yeah.
Okay, Jeff. All right. And then we return. So we'll go ahead and set classroom.
So, if I be done, why wouldn't that stuff be in classroom? Like, why would that be in main or in building? Like the students.
Okay, hold on. I feel like what you asked is very important, but I didn't understand the question. Ask it again.
Probably not. So, like how you were putting information in building, and then your building main is just calling it and getting the information from building, why wouldn't the students be in like a classroom and you just call the classroom? Like, why are you putting this stuff in building main?
This is building main. This is a test program.
Gotcha.
I'm testing here. So we are testing / showcasing building, classroom, and student. Just to show you how you can compose things. Like you can have students inside of classrooms, you can have classrooms inside of buildings. I mean, we could have buildings on top of campuses as part of cities as part of states as part of countries as part of the world, planets part of systems. I'm sure we could start taking this out further and further. But I just want to show you how you can compose things to help you basically with levels of abstraction. Because with the building, you're just really concerned about what's the classroom, does it have a roof, offices, stuff like that. And then when you drill into the room, now you're concerned about what's in the classroom, desks, seats, windows, doors. And then maybe you find a student, then you'd be concerned about that particular student. But if you're looking at a building, you don't need to know all the students that are in the building when you're just thinking about it. But it might be nice to ask the building, hey, do you have this student? And then it can search, hey, look, am I in this
Always
building?
ask the building questions.
Yeah, ask the building questions, right. Okay. Let's see what we got. Okay. Get classroom with the student. Let's first do with classroom name. Let's do this one first. I think it'll be easier. So, what's really good to do is if you have a getter and you know you need to, well, what do we need to do? Before I say it, what do you think we need to do? We're being past the classroom name. How are we going to find out which classroom it is?
Have a directory with all the list of classes, correct?
Array.
So we have that already, the array. So what are we going to do with that array?
Put stuff in it.
We're going to, no, we've already put stuff in it. Now we're trying to find the classroom with the classroom name.
Search the array.
We're going to search the array. So if you're ever going to do some searching, or your function's going to be even slightly complex, what's a good thing to start with, just to make everything easy, is you start with classroom, ret equals null. This initializes a variable called ret on the stack that points to a classroom and initially points to nothing because you haven't found it. And then at the end, you return ret. That way, you have it set up to where if you find it, you just set ret to that variable once you find it, and then later on, it will be returned correctly.
So you'd have a for loop.
All right, so a for
Statement.
int I equals 0, I is less than, what's the size?
The classroom, well, the amount of classrooms.
All right, so m classrooms.length. Any confusion with that for loop? I starts at 0, goes up to the length of the classroom's array, because arrays in Java are objects, and the length is stored with the array itself, incrementing I each time. Questions, comments? Screams of angst?
Wait, what was the last one?
Screams of angst? Angst? Ah!
Angst.
I prefer angst. It just sounds funnier. All right, what do we need inside this for loop?
The new if statement.
A what statement?
If statement.
Mhm.
If the index is equal.
Excuse me. If what?
If the index is equal to the position you need.
All right, how do we check that? How do we go through the indexes of an array? Did y'all do arrays in C++? Yeah, I thought so. So how do you go through the array?
One at a time, pretty much. You start
Okay,
with 0.
I'm just asking for, okay. So in classrooms, what's the next character of the syntax? Try to get everyone to say, yeah,
Check whoever eyes, that's the index.
the brackets.
Bracket.
There we go. Woo. Classrooms dot, well, let's get the, ooh, we don't have a name on classroom? Uh-oh. Let's go back and fix that.
Bad things are happening.
Nope, we just fixed that real quick. Public string get name. Return name. Now we can dot get name, and ooh, what comes next? Let's see who remembers.
If that is like double equal sign thing, and then whatever the classroom name they got that.
All right, then what do we need to do? We'd have ret equal to the classroom. All right. So let's test this. So system.out.println, good old Paul of the West, .get classroom. We'll pass in age207. So that should return something and print something out. Ooh, no pointer exception. Ah, that's good. So there's our first error. Why are we getting a no pointer exception here? Well, let's think about this. We have a building with 6. The first and second elements we put in a classroom. What are in the other ones? No, yeah. Does it make sense to call nothing dot get name? No. Okay. So we need to do a first check. Sub I does not equal null and. So if it's not equal to null and the get name is equal to classroom, go ahead and return it. Any questions about that? Why I had to do that?
Because there could be like a space in the array that there's not.
Yeah, there's nothing in there. And if you try and call a function on a null object, you get a null pointer exception.
So that'll skip over.
Hmm?
That'll skip over and go to the next.
Yeah, you got it. This says first it has to not be null, and if it's not null, then you can check this. Remember, in C++ there's shortcutting, so if you have an and statement and the first part is false, it does not execute the second part. All right, let's try it again. Ooh, came back with an actual classroom. That's good. Let's see what happened here. Oh, I know what happened. We're going to make a new string, age207. We're going to try it again. And this time we get null. I didn't get null the first time, but I got null this time. This is kind of tricky to understand. This is the way Java compiles things, and it's kind of frustrating. And the way to get around it is if you're comparing objects, never use double equals. Always use the equals function. Okay? Don't use double equals on objects. What does double equals actually compare if you're giving it two objects?
You make sure they're the exact same.
It's comparing the memory locations of two objects. It's not comparing the actual contents of those objects. So it's comparing the two memory locations, which at that time happened to be the same over here when I didn't put new string because it was using this string and the one up there to be the same thing. But when I told it to make it a new string object, it was no longer the same string as beforehand, so it would not compare them for equality correctly. Therefore, when you have objects, always call dot equals.
Always.
Yes. Unless you really are trying to compare that they're the exact same object, then you can use double equals. But that I cannot think of a good OOP reason why to do that. Okay, so get classroom. Oh, that's great.
So what is it like outputting right there? What is that?
All right, yeah, what is this? It is a CSU CSCI 325 classroom at memory location 7EA987AC. If I were to run it again, oh, it's at the same memory location. Oh, same memory location. Can we actually rebuild this and have it give me a new one? No, it's going to keep giving me the new one, the same one. That's nice. It just happened to be that the object is always at that memory location for this program. But it may change depending on how your program functions. In fact, I bet you if I did this, just something simple like that, and reran it, it probably would give me, oh, it gave me the same one. That's cute. The memory location might be different at other times. I'll just say that. C++, it changes all the time. But it looks like to be kind of consistent. Okay. All right. Now, what was this next one? By student. So we want to see, we want to get the classroom that has a particular student. Okay. How should we go about that?
Get like a list of, like an array of students then?
Get an array of students. Okay, should the building have the list of students?
No, I guess the office would, right?
Well, the classroom does, right? So the classroom has the list of students. So we really need to jump over to the classroom first. And maybe we could do public student get student, passing in string student name. All right, now we're in the classroom right now. So let me go ahead and make a student ret equals null, return ret at the end. And the classroom, just to refresh, has a name and an array of students. So if I'm at the classroom level and I want to see if I can get a student, what do I do?
For loop, right?
Yeah, another for loop. There we go. For int, not 9, int I equals 0, I is less than m, where we got seats, dot length, I plus plus. And then we check if m, what's the first thing we check? M seat sub I,
It's null. It's
not
not.
null. And m seat sub I dot get name dot equals the student name. Then we'll have ret equal to m seat sub I, and then we'll return it. Okay. So now the classroom can find the student inside of it by name. So if we were back here in the building, I'll go and make a classroom ret equals null.
Do a for loop to go from classroom.
There we go. For int I equals 0, I is less than m classrooms dot length, I plus plus. So if, what's the first thing we check?
It's not null.
It's not null. And m classroom dot get, or what's the other one? Sub I dot, now what was our function that we had? We had get student, right? And then we need to pass in dot get name. Whew. So dot get student. Oh, but it's needs to be a Boolean. So we really just want to know if that is not equal to null. Because if it's not equal to null, then that means it found it. In which case we can then create a, well, which case it means it found it. So we just need ret to equal m classroom sub I. And we're done. I typed that fairly quickly. It's really important you understand what just happened there. The classroom is going to take care of finding a student inside of it. And the building is going to take care of asking each classroom, do you have this student? Do you see how the division of labor was done? I divided the labor out. So I didn't have to go pull a full list of students. I just told each classroom and said, do you have the student? Do you have the student? Do you have the student? Okay. So if we were in building...
You can't do your if line up there on the board. The if line.
What's the question?
Like, what's at the end of that if line? Like, see, it's kind of like off the screen there.
Oh.
Go up. Not equal one up.
Oh, yeah, you can't see that on the board. The screen's a little off, online people. There we go. How about now?
I have a question.
Yes.
So with what you were checking, say you had two students with the same name in
Mhm.
different classes. If they were in different positions, like a different order, would it still go through? Like,
It's going to go through each one, and it'll probably, it would return the last classroom that had that student in it.
okay.
That's just what this function's doing. And maybe that's okay for us, but that's a great observation. Something to keep in mind. So we could have it return the last classroom with it. So we could return a list of classrooms, but we don't want to get too complicated right now. So building main, if I were to, let's see, go in here, system.out.println, Paul of the West. Actually, let's go up here, get classroom. We'll go ahead and get the name. And we'll do .get Paul of the West, .get classroom by the student. What do we want the student name to be that we're looking for? Bob? Okay, great. Thanks to everyone. Get name. So what name? So we'll say right here, Bob is in, we'll run it. Bob is in H208. Let's see. I guess we're going to make it like that. Okay. I'm going to make this 2 lines so it's a little clearer. Maybe space this out a bit. All right, and if we want to know where Tyler is, it's probably going to jump into AH208 and return that one. Okay. Any questions? All right. Hopefully you can see the technical term for this is functional decomposition. What's happening is, and it's called that because you're dividing the functions into different portions or different objects. The point of this is you really should have your object take care of everything it's managing. And then if you want to divide it out like with building, it has some object inside of it that may take care of little specifics for you that you don't care about. And the reason for this is abstraction. All right, a lot of that what I just said was kind of confusing. But the main point here is you have your building object. When you have your building object, it's a lot easier to maybe just think of your building object as it has a name, it has classrooms, maybe some stairs and a roof. It's easier to just think about that as opposed to, all right, it's building, it has this many seats, this many steps on the stairwell, this many windows. You don't really need to think about all that when you're thinking about a building. You just need to think about, roof, rooms. It has stairs at these locations. Maybe we'd add an elevator. You don't care about what type of elevator because you could ask the elevator what type it is. You don't care too much about the classroom because you can store that information in the classroom object. So it kind of cleans up the building object so you can just think about what's the high level or the important aspects. And if you need to drill down, you can just jump in to something like the classroom. Notice we could do something similarly with the offices. We could have an office and then have the professor that's supposed to be in that office. Maybe there's more than one professor in that office, or windows or doors. But do you see how I have decomposed it into different sections? Also note I'm using an object to model a real-world entity. You know, I'm using it to model AH208 or 207. Okay? Yes?
On that, if you go back to, I think it's your building main,
Mm-hmm.
when you were calling the system about outlines, why in the first one did you add the get name?
Right here?
Yeah.
Oh, so it actually tells me what name it is. Because without the get name, it's returning the object, and the default function to print the object is that whole memory address. So, good question. Any others? No questions? All right. Well, let's see how we're doing on time. Perfect. This went well. All right, and that's all for today. Oh, no, that's not all for today. I lied. Let me go and stop.